there's something missing in my stuff here, and I believe I used to have it. Not sure where it's at now, but nonetheless, before we get into EIGRP, there's one thing about RIP that I want you to understand that RIP uses a port number. Okay. Um, I think it's 520. Yeah. Okay. All right. So it's 520. Okay. All right. And you can see down here Wikipedia is confirming because AI. If you rely over AI information, and here's 4520 again. Okay. That needs to go up here just in case. Okay. Now with EIGRP though and OSPF, we don't use port numbers. Okay. We use protocol numbers. Okay. All right. And EIGRP, okay, I believe is port or protocol number. We gotta look that up too. I don't have it on here. Okay. Let's get rid of that and say it is 88. Okay, and OSPF is most likely 89. Okay, so we could actually go here and say protocol 88. Okay, and let's look up OSPF as well, which I believe is 89. And it's 89. Okay, all right, and obviously re-verifying it down here, and again down here. Okay, so we got confirmation. So let's go ahead and copy this, and let's go down here to OSPF, and let's go ahead and put that up here. Okay. Now that means if I actually did a wire capture, okay, which we've never done before, okay, we're gonna have to do that to give you an understanding of what I'm talking about, okay. So in a wire capture, okay, you're going to look at all the layers, layer 2, layer 3, layer 4, that's captured in the packet. Now, if we're not using port numbers, you're not going to see that layer in the capture, okay? All right, and you're going to see these headers in every packet that is sent, okay? All right, and if I actually look at the IP header and see protocol 88, I know this is going to be EIGRP traffic, okay? Now, remember that distant vector, okay? Well, OSPF uses a algorithm to run its concept of what is the best link, okay? All right, or I should say, what is the best path to get to a particular destination, okay? And EIGRP does the same, okay? And EIGRP, if we look at this algorithm, all right, we're going to take 10 to the 7th power, and we're going to divide it by the lowest bandwidth of the path. Now, that part of the algorithm is something that you need to understand. Okay? All right? We're also going to add that to the sum of the delay. Delay is also something that you need to pay attention to. By default, all right, there's only 2K values that I actually utilize. Okay? All right? And you do have, was it 5 K values? Okay? We need to understand that if I turn off bandwidth for a K value, okay, turn it from a 1 to a 0, then the only thing that determines or being utilized in the algorithm is the delay. That means that from router to router, okay, I can physically change the delay value, okay, of the link, okay. All right, I can manipulate it downstream if I want to, or upstream, however you want to look at it, okay. Now, That's only one value. Okay, that's great. Okay, I mean that's perfect. I don't have to even disable the bandwidth path. However, if I want to change the bandwidth, I physically have to go to every router, okay, and document, record, or have an idea of what every value is. Now, the only one that's going to make a difference downstream on that path is choosing the router that has the lowest bandwidth. Okay? Alright? Now, that's the only way I can manipulate the path. It's kind of weird, isn't it? Because that means I could be 5 routers downstream to change, because I know that that's 100 megabits where all my other ones are gigs. So that's the only way I can actually make a path more have a lower metric or a higher one. Okay, it's kind of weird. All right, something we haven't demonstrated, but later on, I'm sure we're gonna get to one of those videos. Okay, so but just not today. We're just doing a review. Okay, this algorithm down here is called the dual algorithm. Okay, and you also gotta understand that not only does EIGRP have a topology table, but it actually has backup routes to a destination. Okay, all right, it's very, very simple to configure from the concept of the moving parts in like OSPF and BGP. Okay, all right, it's fast. All right, its convergence is very fast, and it has equal and unequal load balancing, and that's pretty awesome. Okay, all right, we can use what's called the variance command to say, hey, we'll give this a variance of 5 instead of 1. Okay, all right, with a variance of 5, all right, think of it as the metric could be up to 5 times worse. It's not a science. It's not. It's just a. It's just an idea to make you see what I'm talking about. Okay, and as long as it's within that variance of 5, okay, you can actually be load balancing across a gig link or a 10 megabits per second or 100 megabits per second link, depending on how you configure it. Okay, all right. EIGRP has your neighbor tables, your topology tables, and of course your routing table. EIGRP, unlike RIP, because RIP communicates on broadcast all 255s or okay 224.0. I can't remember. Let's go back over here to RIP. I just moved it, didn't I? Okay, I don't even have the multicast in here. That's crazy. Okay, I'll worry about that later. So now, okay, so um, it communicates on multicast. So here's the thing: if I have 30 routers, okay, in a broadcast domain, okay, I'm only going to be communicating with the .10 with multicast addresses, meaning that I'm going to communicate on this multicast address, but I'm also going to be listening. Okay, all right. EIGRP neighbor by neighbor, okay, uses autonomous system numbers after router EIGRP. Okay, so that's kind of important because you can have multiple autonomous system numbers, meaning that if I want to send routes from one autonomous system number to another, you might have to do some redistribution. You know what I'm saying? Okay, meaning that you're going to be redistributing from EIGRP into EIGRP. Kind of weird, huh? But you have no choice because an autonomous system is an autonomous system. Okay, all right. So from that concept, these numbers, as far as your neighbors, they must be the same. Okay, uses K values for your metric. Okay, all right, and passive interface is something you can do under the router OSPF. I'm sorry, router EIGRP process, just like OSPF, by the way. I can actually say passive interface name the name on an interface like interface G1, okay, that's going to eliminate that interface of of communicating with EIGRP, meaning that you're turning that interface off. Okay. I could also go on the router EIGRP and say passive interface default. That means every interface is now not being enabled for EIGRP, and then for every particular interface, okay, I can say no passive interface, all right, G1, meaning that's the only interface that's going to do it, okay. Either way, okay, it solves the actual issue, okay. Now, your K values, bandwidth, delay, load, reliability, MTU. Okay, if you go into a show interface command like G1, okay, you will see these values are there on the interface. Okay, so by default, bandwidth and delay are the only K values that are installed or enabled with EIGRP. If you enable them all, okay, all right, your K values with you and your neighbor must be the same. Okay, all right, meaning that if you do not do this in your entire domain, your metrics are going to be a little weird. Okay, might not be your best design aspect, meaning that two of your routers have all K values installed, and the rest of your K values in your domain, okay, are not going to match up, which is kind of weird because the only way that for you to really do that is actually have a router that's within multiple autonomous systems, because otherwise you can't have a router specific to a neighbor with K values. A router's K values are their K values. The only way you can change that is go into an autonomous system, meaning that one router will have to have multiple autonomous systems, okay, in order to have different K values. All right, something I've never done before, so maybe we'll do a lab on one of those one day. Okay, all right. You got several types of routes, which is your successors and your feasible successors. Okay, all right. Your successor is the best route. Your feasible successor is your next best route. Okay, all right. Now, your advertised distance, okay, for a route is what your neighbor is telling you their distance to get to an actual route. Okay? You take that advertised distance, okay? All right? And you add it from your metric that you have from your router, and you come up with a feasible distance. Not the same as feasible successor. Okay? So your feasible selection, okay? The administrative distance of the feasible successor must be less than the feasible distance of the successor. Okay? Now, in a lot of ways, now we're talking about the feasible successor now, not the feasible distance. Okay? Already this is complicated. You're confused. Okay? All right? But this is just a review, so we're not going to go in detail. We're going to have a physical video on that concept to get it really through the head. We've already talked about it once, okay, but not in detail. All right, so if that kind of messes with your head, it's okay. All right, we talked about the various command auto summarization. Okay, all right, so hang on. And passive routes and active routes. Okay, so here's the thing. Your auto summarization. We're not going to talk about passive or active routes at the moment. Your auto summarization is a concept of if you have like 10 separate 10 separate class C/24s coming off your router, okay, Auto summarization is going to take that and turn it into a 192.168.0.0 network. Okay. All right. What that means is, and it's still going to be slash 24. That means the third octet. Okay. All right. Is I'm sorry, not slash 24. It's going to be a slash 16. Okay. Meaning that we're going to advertise all those slash 24s, okay, and we're going to summarize it into a single route, making our route table shorter. Not only have to do a simple lookup for all those routes, okay. All right. Now you can summarize even more specifically, okay. All right. And the last thing we're going to talk about is router ID. Okay. ESGP has a router ID. Now, if you have two routers with the same router ID, they won't exchange routes. Okay. You'll be having a weird scenario where my routes aren't coming in. You can't figure out why. Okay. All right. We tend to forget this with ERGRP. Okay. Router IDs are selected by loopback addresses first if they're on the router, the highest loopback address, or if they're not loopback addresses on there, the highest IP address on your router that are physically or physically slash logically defined. Okay, all right, okay, and that's pretty much the basics of the EIGRP. Okay, some of these we've discussed, some of these we have not. Okay, but remember, this is not an in-depth concept of EIGRP. So if it's something that we haven't figured or talked about, okay, all right, and you feel that I'm being vague, it's because I am. All right, okay. So I just want to keep you in mind that any of these topics, any of them, you can actually go out and do your own research and lab them. Okay, but as of now, we have not gone through some of these concepts. Okay, all right, and that's pretty much it. And I'll see you on the next one.